781. The beam consists of a 3-segment pin connected at P and E. So there is 2 pins. You can see pin at E. What is it? Pin E and pin P. 2 pins, which means that you could take this beam off, leave this beam here, and take this beam the other side. So you'll have 3 beam connected with 2 pins. Okay, draw the shear moment diagram. So you can see that there is normal or uniform distributed load, and then triangle loading at the other side. A is a hinge, 2 reactions, and F is a ruler, ruler, ruler. Let's take the first section. Let's take this section, FE, that way. So we'll have 1 reaction in the Y, and the E, of course, it's a hinge, or I mean it's a pin. So this pin will have EX, EY. You can see EY, EX, and there's a loading. The normal loading from F to E, it's 9. So it's 9, and the distance 4. So 9 times 4 going down, 2 and 2, because it's going to be in the center, it's rectangular, and Fy. The best using this process is to do summation moment at this point. Fy is going plus times 4, and 9 times 4 going negative times 2. So we'll end up with Fy equal 18. And then you could find summation of forces at the Y, Ey up, this is down, and we know Fy, so you could find Ey, summation of forces at the X equal to 0, Ax equal to 0. Now, we took this. Now let's take the center. Okay? Let's take the center. The center, remember, has 2 unknowns. Let's take the other side here, this one. Take it away. Since there's a pin, we'll take it away. It's only a triangle, and there's 2 reaction, and this P, X and By. So we'll take it like this, Ax and By, the hinge, 4.5 meter, remember, 4.5 meter. And remember, it was a triangle, so 1/2, 9, 9 was, remember, 9. This is the triangle, the maximum here is 9, so 1/2, 9 times 4.5. 1/2, 9 times 4.5, and it's going to be 1/3 of, remember, 4.5. So this is 1.5, and the rest is 4.5 minus this. This is it. This is the hinge, Px and Py. Whatever, if you're going to make it plus and plus, let's make it plus and plus. Plus in the x-axis, plus in the y-axis, so we could see if later on will give you wrong results. Summation of moment at A, Px is in the line of action, don't worry about it. You could find By in the plus, times 4.5, and this one, 1/2, 9, 4.5, and this is going in the negative, times 3, times 3. This would give you Py 13.5 kilonewton. Summation of force of the Y, Ay minus this, plus this, and By we have it, we could find Ay. Summation forces at, you don't need to find the axis, because this is shear moment diagram. Shear moment diagram, we don't need Ax and Bx. Now let's take the center. The center here, these 2 hinges. We did this, analyze it, we did this, we analyze it. Now we'll take the center. So the center, remember we found Ex and we found Ex and Ey. Ex was 0 and Ey was up. So if Ey was up here, 18, Ey gonna be down. Ey, Ex, you can see Ay is down, and Ay was given here what? Because it's the same magnitude, opposite in direction. This is Newton's law. Ay is 18, so this Ay would be 18, it would be down. Ax is 0, so you don't have to worry about this. Dy Cy, because the reaction is DC. So dy/cy, and this is, we assumed it's bx that way, so it's going to be bx that way, by that way, and this one going to be by that way. Opposite in direction, same magnitude. And now we could put the same intervals, and the whole thing was what? Here you can see it, it's uniform distributed, so it's 9 times 2, 2, 2, 9 times 6. So you put 9 times 6, and it's in the center. It's 3 and 3. You could find summation moment at this, since you have by, so hold on, since you have by and you have ey, so we don't want to make moment at the point B or E because we have them. Why we have to make moment at these points? We should make moment at point C to cancel out C and cancel out the bx and the ex in the same line of action to find dy. Okay? dy. Summation forces at the y then, down, up, up, down, down. And you could find Cy 36 kilonewton. Once we find everything now, we should put the numbers. We should put the numbers of all the reactions. 6.75 kilonewton, and Hench 36, 49.5, and then 18. And of course it's 9 uniform all the way here, and then it goes down. Now, to draw the shear diagram, shear is V, and everything is in kilonewton. So we put kilonewton here, and we put X meters. So the shear will start going up. Look at this, going up. At this point is 0, gonna go up 6.75. And then you can see that the shear will be reduced at this point, what? 1/2 9, this is 9, times 4.5. So 1/2 9 times 4.5, that's down. So we could do it like this. 6.75 in the plus, and this is going down. So minus 1/2 9 times 4.5, which is the equivalent force in this triangle. That's going to give you minus 13.5, which means that it's going to go all the way from here to minus 13.5. And this is going to be concave down because this is linear. So you are at the minus 13.5. So now you go from here to here. Okay? So you'll have what? 9 times 2, 18. So minus 13.5 minus 9 times 2. Minus 31.5, and since this is uniform, you'll have linear, not concave down, minus 31.5. And now we have here 36 up. Look at this, 36 up. So you go minus 31.5 plus 36. This is going to give you 4.5. So you're going to go up 4.5. And now you have from here to here uniform, but it's down. So 9 times 2, 18, down. So 4.5 minus 18. So 4.5 minus 18, that's going to give you minus 13.5. So it's going to, and this one is uniform, so it's going to be linear, minus 13.5. And then you're going to go 49.5 up. So minus 13.5 plus 49.5 is 36. And then you have this distributed. 9 times 2. Down. 36 minus 9 times 2. 9 times 6. Ooh, let's see. We are here. Oh, there's nothing here. There's no forces up here. So there's no reaction. Okay, good. So 9 times 6. 2 plus 4, 6. 9 times 6. There's nothing here. We take these pins for the moment, not for the shear. So from here to here, it's 9 times 6. 36 minus 9 times 6 is minus 18. So you go from 36 all the way to minus 18. And those 18, now we confirm that this is correct solution. Remember, concave down. Why? Because it's linear. Linear. Why? Because uniform. Everything else is linear because the load was uniform throughout. Now, there's a problem with this one. The problem is we cannot find the area under this curve and under this curve because it is concave down. It's difficult. So the way we do it is find out, we should take a section here and take the shear and moment just before this hinge and find the shear. You could find my moment too. So let's take this section, and of course AX is, don't worry about it, 6.75, and let's assume this one X. The equivalent force, if remember, this one was 4.5 and this one was 9. So 9 is double 4.5, okay? Which means that X, I'm going to make this one 2X. So what is the equivalent loading? 1/2 2X times X. Okay? So 2 with 2, X squared. That is the equivalent loading. I'm going to assume that there is a shear down and a moment that way. I'm assuming. So if it came negative, that's going to be resolved later on. The distance here, it's 1/3 X because it's X and 1/3 X, and this is 2/3 X. Let's find summation forces in the Y. Up, down, down. This is the shear equal to this. So we know now the shear in terms of directions, okay? Let's find moment. Summation of moment at 0. So we'll take moment at this point. So we could take the shear off. This is going to go plus, and this is going to go negative. So plus, of course, the moment that we assume that we have to take care of. It's going to be like that. So the moment is equal to 6.75x minus 1/3 x cubed. Now, remember here that there was a zero shear. So this zero shear happened at this location. We could make V 0 and find x if you want to. Now, so at zero shear, we could find x. So because here there was a zero shear, and zero shear there is a moment that's really high. We know this by definition. So we know that initially moment here is 0. So moment here is 0. Now we know that here there is zero shear, so you'll have some maximum moment. So this maximum moment, how could you find it? By doing, let's find the x. Zero shear will give you the x. X squared will give you 6.75. So x, the square root of 6.75 will give you 2.6, which means that this distance is 2.6. Now we have this equation. We put 2.6 here to find the maximum moment, because at this zero shear there's a maximum moment. So at this zero shear you'll get this x. At this moment you put the 2.6, you'll get moment 11.69. And since we have, remember, we have a pen here, so automatically it's going to go to 0. So now we are safe. Now we have everything linear. Everything linear, you have to find the area then, at the end of the curve. Remember here there is one triangle and one rectangular. So find the area of this. Add it up, okay? So you can find minus 45. Okay? This time it's gonna be linear, so it's gonna be non-linear here, and this is gonna be an additional. This is minus 45. So you do it like this. Initially it is, let's see, how could you do this? Minus 13.5 times 2 minus 1/2, you can see it here, minus 13.5 times what? 2. So you could know the area of this. We could find the area of this. Let's bring a pen. So, this rectangular minus 13.5 times 2. So minus 13.5 times 2. And then there is the triangle minus 13.5 and 31.5. You should find this, subtract this from this, you find this, 1/2 times this times 2. 1/2 times 2 is 1. 31 minus this, it would give you this one. So it's minus 45. So you're going to go to minus 45. Now you have minus 45. So remember, here there was a higher moment at V0. You should find the distance from here to here. This is 4.5, 13.5, bigger triangle, and make small triangle, and find this distance, and find 1/2 this times 4.5, 1/2 this. This is the big triangle, small triangle. It's the same process over there. X is 0.5, 1/2 4.5 times 1/2 4.5 times 0.5, because this 4.5 times 0.5, you'll end up with what? 1.125. So 1.125 minus 45, you'll get minus 43.9. And then we are here now. You find the other triangle. This is minus. The other triangle is 1/2 times this, minus 10.125. You add it up to the other one, so it's going to be minus 54.025. And then remember, here you have a pen. So it's going to go all the way to 0 at this pen. And then the rest is by finding, the rest is by going to the 0 and then by finding the interception here. So you have to find out the interception here, and then from this you could go and continue back to 0 at the back. Okay?